96%. Not 96% of one species, not 96% of one ecosystem. 96% of every living thing on this planet, gone. No asteroid, no sudden impact, no single catastrophic moment you could point to and say, that's it, that's what did it. Just the Earth itself, slowly, methodically, turning against everything that lived on it. This is the Great Dying, and it is the closest life on Earth has ever come to simply not continuing. Picture yourself standing on the shore of Panthalassa, the single super ocean that covered nearly 70% of the planet 252 million years ago. The water is warm, warmer than any ocean alive today. The sky above you is clear. The air is breathable. Around you, in the shallows, in the forest behind you, in the soil beneath your feet, life is everywhere. Complex, thriving, evolved over 300 million years into something extraordinary. You have no idea that in geological terms, you are standing at the end of the world. The late Permian was not a barren, hostile world. That's the part that makes what happened so staggering. By 252 million years ago, life had already been evolving for over 3 billion years. The oceans were packed. Trilobites, brachiopods, coral reefs covering vast stretches of the seafloor. Fish in numbers that would dwarf anything in today's oceans. On land, the dominant creatures weren't dinosaurs. Dinosaurs hadn't happened yet. The rulers of the Permian were things like gorgonopsids, fast, warm-blooded predators with saber-like fangs, and Dimetrodon, a sail-backed reptile that sat at the top of the food chain for millions of years. Pangaea, the single supercontinent, stretched from pole to pole. Forests covered the equatorial zones. The poles had ice. The deserts had their own complex ecosystems. This was a world that had survived 4 mass extinctions already. It had endured ice ages. It had endured asteroid impacts. It had endured volcanic winters. It was, by every measure available to us, a resilient planet. And then something happened that resilience simply could not touch. Here is what makes the Great Dying so uniquely disturbing, and what separates it from every other mass extinction in Earth's history. It wasn't fast. An asteroid impact is fast. The Cretaceous extinction, the one that killed the dinosaurs, was fast. A rock hit the planet, the sky went dark, temperatures collapsed, and it was over within decades. The Great Dying was not over in decades. It wasn't over in centuries. It took tens of thousands of years. And every single one of those years, things kept dying. So, what actually started it? What could cause that kind of slow, sustained, total annihilation? That's what we're going to find out. It started with the ground, not with a single volcano, not with an earthquake, not with any event you could look at and immediately recognize as the beginning of the end. The Earth's crust across what is now Siberia simply started to crack open, in thousands of places, simultaneously. Lava didn't pour from one mountain. It flooded out across an area roughly the size of modern Europe, in volumes so enormous that geologists today still struggle to communicate the scale accurately. These are called the Siberian traps, and they didn't erupt for a week. They didn't erupt for a year. They erupted continuously, relentlessly, for somewhere between 1 and 2 million years. Every year of those million years, they were pumping carbon dioxide, sulfur dioxide, and methane into the atmosphere in quantities that had no precedent in Earth's history. The planet had no framework for what was about to happen to it, and neither did anything living on it. Minor geological inconvenience, barely worth mentioning, unless you happened to be a living organism anywhere on the planet at the time, in which case it was, in fact, very much worth mentioning. Here is how the Great Dying actually killed things, not in one way, in 3, simultaneously. And each one on its own would have been catastrophic. The first was ocean acidification. All that CO2 the Siberian traps were producing didn't just stay in the atmosphere. The oceans absorbed it. And as the oceans absorbed it, their pH began to drop. They began to acidify. For marine creatures that built their shells and skeletons from calcium carbonate, this was a death sentence that arrived slowly, invisibly, and without any possibility of escape. Their shells began to dissolve. Coral reefs, which had taken millions of years to build, started collapsing. Marine invertebrates that had survived the previous 4 mass extinctions began dying in numbers that had no precedent. The second was heat. Global average temperatures rose by an estimated 8 to 10 degrees Celsius over a period of less than 100,000 years. To put that in context, the difference between an ice age and today is roughly 5 degrees. The Permian wasn't cooling into an ice age. It was heating in the opposite direction, twice as fast, with nowhere near enough time for life to adapt. The third was the one that finished it. As the oceans warmed and acidified, their ability to hold dissolved oxygen collapsed. Dead zones began spreading across Panthalassa. Not low oxygen zones, not oxygen-depleted zones, but zones with no measurable oxygen at all. Spreading, expanding, consuming the seafloor, then the mid-depths, then the shallows. The ocean wasn't just dying, it was suffocating, and it was taking everything inside it with it. Go back to that beach, the one where you were standing at the start, where the water was warm and the sky was clear and the ocean was full of life. That ocean is now the color of rust. The smell hits you before anything else. Hydrogen sulfide rising from the water in slow, visible clouds. The gas of rot. The gas that signals something has gone deeply, fundamentally wrong beneath the surface. The sky above Panthalassa has turned a dim, sulfurous yellow. The creatures in the shallows aren't moving. The reefs that were there 10 minutes ago are bleached white and crumbling. And the worst of it, the absolute worst of it, is that this has been happening for thousands of years. What you're seeing isn't the beginning of the end. You're standing somewhere in the middle of it, and you have no way of knowing how much longer it has left to run. When the dying finally slowed, and it took tens of thousands of years to slow, what remained was almost unrecognizable as the same planet. 90% of all marine species, gone. 70% of all land vertebrate species, gone. The forests were gone. The coral reefs were gone. The gorgonopsids, the Dimetrodon, the complex food webs that had taken 300 million years to assemble, gone. What was left, shuffling across the scorched and nearly lifeless surface of the new Earth, was a creature called Lystrosaurus, a stocky, pig-sized herbivore with a beak and 2 small tusks. Not fast, not particularly intelligent, not fearsome in any way, but alive. At the peak of the post-extinction world, Lystrosaurus made up an estimated 95% of all land vertebrate life on the planet. Not 95% of one region. 95% of everything, everywhere on land. One species, an entire planet, and nothing else. The undisputed king of the entire planet, dominant across every continent, master of all it surveyed, a glorified pig with a beak. Extinction, it turns out, has a very strange sense of humor. But here's the thing about the great dying that nobody tells you. The extinction didn't just end a world, it built ours. And what that means for you, specifically personally, for the fact that you exist at all, is the part of this story that should genuinely disturb you most. Here is the part of the great dying that nobody in school ever told you. The extinction didn't just end a world, it decided what the next one would look like. In the tens of millions of years following the Permian extinction, the ecological vacuum it created allowed an entirely new class of creatures to rise. Creatures that had existed before the extinction, but only at the margins. Small, fast, adaptable things that couldn't compete when the dominant predators were still alive. With the gorgonopsids gone, with the Dimetrodon gone, with the complex, established food webs of the Permian wiped away, something new moved into the space that was left. Those creatures eventually became the dinosaurs. The dinosaurs dominated for 165 million years, then met their own extinction. And what survived that extinction, again small, again adaptable, again living at the margins of a world dominated by something larger, were the early mammals. The early mammals that, over the next 66 million years, became us. Every human being alive today is, in some deeply uncomfortable way, a direct consequence of the worst catastrophe in the history of life on Earth. Stand on that beach one final time, not as a visitor, not as an observer. Stand there knowing what you know now. The ocean is dying around you. The sky is yellow. The creatures that ruled this world for 300 million years are taking their last breaths in the shallows at your feet. And somewhere, in the ash and the silence, in the ruin of what this planet used to be, something very small is still moving. Something that doesn't know it just inherited the Earth. Something that doesn't know that 252 million years from now, it will be reading about this moment on a device it built itself. That something is you, just further back than you've ever been asked to imagine. You're welcome, by the way, from the extinction that had to happen so you could exist to be disturbed by it. The Great Dying didn't end life on Earth. It just decided which life was worth keeping. And it didn't consult anyone before it did. The Great Dying left behind an ocean. Not the oceans we know today. Calm, mapped, understood. But Panthalassa, the single super ocean that covered 70% of the planet before the extinction and survived it. A body of water so vast, so deep, and so fundamentally different from anything alive today that what lived inside it doesn't have a modern equivalent. We've talked about what happened on land. Next time, we go underwater. And I promise you, whatever you think prehistoric life in the ocean looked like, you are wrong. That's the next video on Veloxion. Don't miss it.